Okay, this is an interactive session, so I need you to respond. Everyone Trackvis up? Yeah. Cool, good, okay. Now, this is what you'll see when you fire it up. You're gonna have a display window on the top, where you see all the magic happening and the pretty pictures. Down here, you will see a brain in a minute, and this is where you do all your drawing. Then here you have the so-called image panel and regions of interest. This is where you load maps and where you create regions. Then here you have the overview. So this is your output panel effectively, where you see what you've done. And here is the properties. So here's where you find the names of things, where you find names, you can rename stuff. And you can also extract your statistics there, okay? Now you should all, just gonna see if we can get the screen in. There we go. You should all have downloaded some data. Where did I put it? There you go. You should all have a folder called Workshop 2025. In there you have an MNI 152 brain. You have the to do before text file, which I'm assuming, given that you're all fired up, you've done. And then you have two files. You have a normalized participant 1 and a normalized participant 2 TRK file. These are your track files. Right, so what we're gonna do is we're gonna start loading them. So the first thing you do is you go to File, Open Track or Scene. And when you do that, you have to navigate to the folder, which I conveniently just dropped on my desktop. And it will allow you to only open the TRK file. So File, Open Track or Scene, navigate to the folder, and we're all gonna open participant number 1 TRK file. So once we do that, ta-da, we see colors. Now, what you can do in the top window is you can grab it and rotate it. It takes a while to get your orientation. So if you end up in a tilted orientation, you can't go back. You can just right click or control click and reset the screen. The other thing that might happen is that you're too enthusiastic and this happens. That's just double clicking on the screen. So you can always make it big and small. Now, the other thing you can see is that if I turn it to the side, you can already appreciate we have a brain shape, but it looks a bit empty, right? We would expect a bit more tracts in there. And that is because you see the white box. That is effectively a region of interest that is preloaded when you open the program to show you all the streamlines that go through this plane. And that's what we use as a sanity check to quickly have a look. Is the arcuate green? Do you remember what the colors were? Nodding is not an answer. What's green? How do we call those tracts? Associations. What was blue? Projections. And red? Commissural is correct, which is in here. You can see the red. Okay, so fair enough, we did a decent job pre-processing this data because the connections are going in the right way. Now, obviously down here, we currently have white boxes, which is not ideal. So you want to go to the head with the green plus to load a map. And if you do that, it lets you open the MNI 152 map. Here we go. Let's put it here. Right, so you can open the MNI 152 map. And now you see a brain down here. Okay, so quick recap, you go to File, Open, Track or Scene, navigate to the folder that gives you the TRK file on the top image, and then you go to the green head with the plus, and you open the M&I 152. Okay, so now you can still see what I showed you just a minute ago, that this brain is not filled with connections as we would expect it. And what we do first, and you always have to do that, is always the first step when you start doing the dissections. You go to the overview panel and you right click on track 1, and now you got to be strong, you delete it. So now the white box is gone, but so are our connections, sadly. Okay, but don't worry, we're going to bring them back. So what you can do is you can drag those boxes back and forth to maximize the view, because we're now starting to draw at the bottom panel. I maximize that one. You can also, and this is where Mac and PC may diverge, but you can also zoom in a bit. And Shift or Control will either change the contrast in the image, or you can position it differently. So we're going to have 2 hours of dissecting a couple of tracts. We have to leave the room at 5 o'clock, I was just told. So let's see how far we get. And in the program, I promised to do the language network, which I happily get to. But I usually start off with the corpus callosum just to get you familiarized with the software. And then we start from scratch and do the language network. Okay, now, first bad news. If you do tractography this way, it's obviously manual dissections. So you have to know your anatomy. So when I say we start with the corpus callosum, you should know where that is. So the first thing you do is we go to our region of interest down here, and we create a new region of interest. And we're going to start with hand draw. So down here, region of interest, new region, hand draw. Now, once you select that, 2 things happen. Number 1 is you now see in the overview your first region of interest, and it automatically unlocks this menu where it selects the pen and the box. Now we want to change from the box to the wiggly line because we freestyle our drawings. So change it from the box to the wiggly line by just clicking on it. Okay, now it's time to do some drawing. So the easiest is on the mid-sagittal. We see the corpus callosum nicely here. 2 things to pay attention. What's this structure just underneath? Fornix. Fornix, correct. What is the fornix? It's a white matter. It's a white matter tract. Do we know which group?
So it connects the hippocampus to the mammillary bodies?
Yeah. It's a tricky question because it gets classified differently. Because in this part, it has a longitudinal orientation, but then it branches down and it splits, which is when it's often classified as a projection tract. But also in the middle, it's one tract. So it sometimes gets picked up as a commissural tract, even though the orientation is longitudinal. It's a slightly tricky question. But the point is we need to stay clear of the fornix, because if you include it in your region of interest, you also get the fornix. What's right on top of the corpus callosum?
Cingulate.
The cingulate. What's the white matter in the cingulate?
Cingulum.
Cingulum. What class of white matter is it? And quiet.
It has to be association.
It has to be association, and it is association. So your job now is to stay very cleanly within the white box of the corpus callosum. Okay? And I'm gonna do that here.
How can we get rid of that yellow cross?
Right, let me just finish the outline. The yellow cross you get rid of by unticking the X, Y, Z boxes down here. So if you do that, they disappear. Okay, who needs more time to do their outline? The brain. So if you untick the pen, then it stops drawing. You have a eraser and you have back. Okay, who needs more time still? No one. Great. Okay, so now we all have an outline. I'm just going to change the color so it's a little bit easier for you to see. Yes, that's better on the screen. Okay, so the next thing we want to do is we use the bucket down here to fill in the structure that we just drew, okay? So you select the bucket and you fill it in. Now, if your entire screen just filled up with color, it means you didn't close your structure, okay? If that happens, you just use the undo button right here and you make sure you close it. Yep. Because I unticked my, here we go. If you untick the boxes here, it disappears. Okay, everyone filled in? Great. Okay, so the next step is, you see here in the overview, we have our region of interest. If you right click, you can create a new track group based on that one region of interest. Yes. So I filled in by selecting the pen and the bucket down here, and I clicked inside my outline. Okay. So if you right click on your region of interest, you should have your tracts back. Yes.
How does it select which tracks it shows? Is it the plane at the center of the...
Yeah. So the way Trackvis visualizes the tracts is you give it a region and it shows you all the tracts that go perpendicular to that region of interest. In this case, right? So anything that goes through this region will be visualized. Okay. So now on the top panel, you can rotate it, you can have a look. And if you remember what it looked like when we opened the very first one, you can see we now have a much fuller corpus callosum with lateral projections. Now, you've had a lot of methods talks this morning. What do you think? Do we only have the corpus callosum? Do we have artifacts? Do we have other tracts?
We have a lot of other tracks.
We have a lot of other tracts, says the neurosurgeon at the back. Which ones?
The uncinate.
The uncinate, okay.
Corticospinal, a little bit.
A little bit corticospinal, yeah. Anything else you want to offer? IFOF, yeah. Anything else?
Fornix.
Fornix, yeah. Anything else? Projection fibers, correct. Okay. Now, this is because, as you learned this morning, there is some areas where resolving crossing fibers is difficult, and you can see that it happened right here. So here is, do you know what this part of the corpus callosum is called? So the splenium or the forceps major goes through the splenium of the corpus callosum into the occipital lobe. This one goes temporal.
Small tapetum.
Tapetum, correct. So this is the tapetum of the corpus callosum. And you can see we have crossings here with the inferior front occipital fasciculus. And that's where it didn't get resolved. So we're jumping the tract. And then it comes back here, and that's why we're picking it up in this case. Okay. Now, what you can do is you can create exclusion regions to get rid of them. And in order to do that, we have to create a new region of interest. So first step, so we don't get confused later, is that we rename our region 1. And you do that by going into first selecting it in the overview. So you select your region 1, and then we go down to the property and we rename it. And I'm just going to call it CC for corpus callosum. Okay. Now at this point, especially if your computer is not the youngest, it's good to save everything. And you do that by going to File, Save Scene As. And then it will ask you if you're sure that you want to save it all. And yes, you are. And I'm just going to call it Workshop Bordeaux. And I saved the scene. Now, the beauty here is if you do crash, you can reopen the scene and it will bring you right back to where you crashed. So ideally, you're not falling behind. Okay. So we all saved. We renamed our region to CC. Now we need a second region that's an exclusion region. And I already said that ideally you want to be perpendicular to the regions that you draw. Now, obviously, that's a little bit tricky here. But for the sake of the workshop today, what we could do is just put a sphere right underneath, because we have this beautiful round shape here for the corpus callosum. So if we just put a sphere in the middle, we should capture them all for today. Now, the way I do that is I first untick the pen, and that means I can now jump around in my image again. And I select the thalamus underneath. And then create a new region of interest. And this time I select a sphere. Okay. New region of interest, sphere. And you will see a tiny dot appear. Okay. Now, this is obviously not going to capture any of the fibers we don't want. So what we can do is in the property window, you can see the radius is 1. So what we do is we're just going to increase the radius. And I have to move it a little bit down. Okay, so I now have a radius of 22. But make sure you're not touching here your actual region of interest. Now you can already see that this will capture some of the projections, some of the fornix, some of the corticospinal tract. We will not yet capture the IFOF and the anterior commissure that we have here. So what you can try is you can try and make it bigger, but at some point we will be constrained by our region of interest, okay? So don't make them overlap.
Then we need to add like another.
Then you would need to add another, yeah. Or you start off by, you just add another. Okay, so save. And I'm going to rename this sphere. Good thing I just saved. That means I get to show you how it works. So if that happens, you go to File and you open the last scene, and ideally, boom, nothing happened. So what I was going to do is rename my sphere to not CC. Not CC. Okay, so obviously nothing has happened just yet. So what we do next is you see in the overview panel, we have our regions of interest and we have our track groups. So far we created one track group, which is the corpus callosum. So if you select track 1 and you right click or control click on Mac, you can toggle your 2 regions of interest, and toggle literally just means combine. Okay. I love it. Half an hour in and Valentina says, now I know what they're doing.
We don't put out.
Okay, so what I want you to do is toggle your corpus callosum region with your not corpus callosum region. And then you should have a very sad reconstruction like this.
Exactly.
Good. Give this a pointer at this point. This is perfect. We're gonna fix it. Now, any idea why we have such a disappointing reconstruction at this moment?
Yes, it was being used both parts combined with the parallelize, so we track the passes, so 2 parallelize instead of.
Correct. So both of you got it right. What we're seeing at the moment is a preview of all the streamlines that go through both regions that we just drew. So this effectively is a preview of all the things we don't want. Okay. Now, how do we tell the software this? In the property windows, there's an option called ROI filters. And if it's not expanded, there's a little triangle next to it that you can click and it will show you the regions of interest. And you can see that for both our regions, we currently see any part that goes through them. Now we want to change that to no part, okay, for the sphere. And now it should look better. Good. So now deleted all the artifactual reconstructions underneath the corpus callosum. And as we knew, we still have the IFOF and the anterior commissure here. So what I can do is I can add another region. No. Okay, just delayed. Save. I can add another region to go perpendicular here to cut them out. If you have them as well, you can do that with me. And perpendicular means we're going to bring this one back so I can see when I catch them all. And now you can see that I'm piercing through the coronal slice here. Okay, right here. So if I now create a new region, I'm going to go for hand draw. And just put a box here. You can see I captured them all. I'm going to put one down here as well. And I can do the same thing on the other side. And you can see I got them all. Okay. I created a third region and placed it next to the sphere to capture the longitudinal ventral connections. Just a box, just a new hand draw region. Yeah, so I went to region of interest, hand draw, and then selected the box to capture them all. Just make sure you save in between. And then we do the same thing. I go to my region, sorry, track 1, right click and toggle. And I add the new region that I've just done.
Like 2D, right?
The 2D one, yep. Okay. Have you all toggled? And then again, you get a preview of everything that will be gone. And now you see we nicely get rid of the IFOF and the anterior commissure by changing it to no part. Okay. So this is good enough. This is just to warm you up, right? So we're not beautifying it any further than we currently have it. But anatomically, I mean, we're going to beautify the dissection. So the first thing we do is we go to region of interest up here in the overview, the very top one. And you right click and you hide them all. So that looks better. So top one, right click, hide all. That hides all your regions of interest. Next thing we can do is in the property window, we have rendering options. Okay. And one of these options is called color code. So right now the colors are based on the orientation of the streamline, but you could change that to either a solid color or a scalar map. So we're going to go with a scalar for now. And this is how you can map your FA map and HMOA map onto the chart. Okay. Now, this is obviously just a toy example. This is not actual statistics. So we're just gonna, in this case, change the threshold. So underneath the color bar, once you selected scalar, you can see it loaded the HMOA map. And then you have the spectrum of colors, and underneath you have the threshold low and high. And because the track right now looks a bit boring, and this is a toy example, I repeat, we're just gonna change the threshold until it looks cool. Now, once you actually have real data, this is not what you do. Let me repeat. Then these are meaningful tracts.
Sorry, I got lost after so hide them all, but then I didn't find where you can change the fill.
In the property, there's a rendering panel. You may have to scroll down a bit.
Okay.
And there you have the color code, which I changed from directional to scalar. And then I just brutally lowered the threshold to make it pretty. Okay, there's one more thing I want to change in the render because this is not publication ready yet, right? This doesn't look fantastic. So there's an option here called render, and it's currently set to line. But we can change that to tube. Just make sure you save before, because this is quite heavy on your working memory. So now I have tubes, but again, it doesn't look great. So if you open the little triangle here under render, you can see more options. And right now the radius is 0.05, which means our tubes are tiny. So we're going to change this threshold. And the magic number you're aiming for is 0.45. And now if I unclick my background and tilt this a little bit, you can see that you've just created a cover figure. Okay. You can change the background as well by right-clicking and set the background color. Okay, so you can take a picture now, either screenshotting it or save a screenshot. And then just to save some working memory, I'm going to go back to line. So we're less likely to crash. Okay, this is now a very pretty reconstruction, but what you need in the end is the statistics, right? So in the property window, if you go all the way down, The last option you have down there is statistics. And you can see that you get some stats, just like this, the track count, the voxel count, the volume. And then down there, it says more stats view. So if you click on that, that opens up an entire new interface where you can get your mean values here. So currently it's set to length, but if I change that to HMOA, for example, or FA, this will be your mean FA HMOA value across the track that you just dissected, and this is what you use for your statistics. Yeah. So in the property window, all the way down, you have statistics, and where it says more stats, you can click on view. And that opens up this new interface. And once you have more tracks, you can select your track and you can also select your option. So this could be FA, mean diffusivity, HMOA, whatever you have as a map. Now we're ready to save the screenshot, save the scene. And then you can either close it and reopen, especially if your computer is struggling a little bit. If not, you can just right click on track 1 and hide it. And it'll disappear. If you restart, then you have to go back to File, Open Track or Scene, load the TRK file, go to the green head, sorry, the head with the green plus, and open the MNI image. And then you delete the first track, okay? Right, are we ready for the language network? Okay. So how would you start?
Like language areas, I guess.
Language areas. How do you define language areas?
And take an atlas, imagine.
You can take an atlas, yeah. If you had to take a wild guess now, which parts of the brain would you include?
Inferior frontal gyrus.
Yeah.
And what will correspond to Wernicke's area, which would be is it STS or is it more no, is it the superior temporal sus or the
No one really knows. There's a huge debate. But for the argument of today's session, we're going to go with the posterior temporal cortex. So we're going to go STG, MTG, which includes the STS. So the way to orient yourself, the way I usually do it, is I zoom into this panel where you see this heart-shaped part of the inferior frontal gyrus. That is what we commonly consider Broca's area. And then here, what's this structure? Sylvian fissure, lateral fissure, yeah. And that separates the frontal lobe from which lobe underneath? Temporal lobe. And in the temporal lobe, you see that we have this gyrus sticking out. Any idea, except for the neurosurgeon? Any idea what gyrus this is? Where are the language people? Heschel's gyrus or the transverse temporal gyrus or primary auditory cortex. So this is quite easy to identify. So in terms of placing our region of interest, I would, as I said, for argument's sake today, we're going to go for the posterior temporal. So anything posterior to Heschel's gyrus is what we're going to include. And we're going to include the heart. Plus, you see this sulcus here. Any idea what that is?
Central sulcus.
That's the central sulcus. Super. What is the gyrus in front of the central sulcus?
Precentral.
Precentral. Fantastic. In terms of functions, what does it do? Motor, correct. So we know the arcuate fasciculus reaches the ventral precentral gyrus. So we're going to place a region that covers the ventral precentral parts of Broca and a second one posterior to Hashot's gyrus. Good? Okay. So the way we do it is I'm going to click on the intersection right here where we're at the ventral precentral and just posterior to Broca's area. And I'm going to create a new region of interest and I'm going to go for a sphere. So the 3D sphere. Again, this is a tiny, tiny region, no good to us. So you click on property region of interest. And again, the radius is 1. We're going to increase the radius until we cover the ventral, precentral, and posterior Broca's area. You want to save in between. And I'm also going to rename my region of interest as currently called Sphere 1 into IFG for inferior frontal gyrus. Okay, we need a second region that we put in the posterior temporal. So we're going to go back to region of interest and create, oh, sorry, let me stop. First click into the posterior temporal. And then we're going to create a new region of interest, a sphere. And again, we have a tiny, tiny region. And we're going to increase the radius to stay within the temporal, but posterior to Hashot's. And I'm just going to change the color so they don't look the same. So I thought, for the record, you don't usually crash this often. It's just Trackvis and Zoom is a bad combination. Okay. So if we now generate a track group from either of those two spheres, what do you expect to see? The arcuate? A lot of different tracks. Both answers are correct. So I'm going to start with the IFG. Right click and create new track group. Okay, so if we look at the screen, you hopefully have something similar. So we're bang on the arcuate here in green as an association tract, and we can see that our second region of interest is in the right place. But if I rotate, you can appreciate we're picking up a lot more. So any idea what we're picking up here? What's this connection here? Let me rotate it. We're talking about this one here. Okay, so the callosum is in red. And if I put in the brain, that might be helpful. There we go. That was helpful. Okay, so you can see the red ones here are the corpus callosum fibers. And here we're going from the inferior frontal all the way up to SMA, pre-SMA. So that is the frontal Aslan tract. So that one we're picking up the callosal fibers, and then we're also picking up, what's this one here? Hang on, let me give you a brainy reference again. That seems to do the trick. Now, which one? Pyramidal tract, yeah. Cortical spinal tract, generally speaking. Okay, we're going down this one. Now, we don't have to clean those tracts in this case because we actually want to toggle it with our second region. Because we only want to see what's going between those two. So if we go back to overview, track 1, right click and toggle, you can now combine your inferior frontal region with your temporal region. And that ideally should give you a beautiful arcade. Who has something other than this? I love that. No one says yes, but suddenly everyone is talking. Okay, so you all have some version of the arcade. If you look around a little bit to your neighbors, you can already see the variability that there is. We're all dissecting the same brain, but we have very different dissections. You need to do a couple before you're reliable. So don't expect to just fire up the software and be reliable. You can see the variance that we have. Okay, so save, and then we're going to do some housekeeping if my computer lets me. So the first thing is I want to rename it. For you, it's probably track 2. For me, it's track 1. And I'm going to rename it as AF_L. Any idea? Left side, good suggestion. Any other suggestion?
Like the whole thing.
The long segment of the arcade, yeah. Okay, and then for the arcade, we have a classical color scheme. So we're going to change the color to make our lives easier. And in that case, we're going to change it to a solid color. So in the property window, rendering, color code, change it to solid. And you can choose any color you want. What is going on? You happy I crashed? Here we go. So I'm just not going to rename anything anymore. It's just not liking it for whatever reason. But I will try and change the color. And the classical color for the long segment is red. So that is your arcade. You can already see anatomically that we're going beyond Broca's area in the frontal lobe. If you use a classical DTI acquisition, as Flavia explained this morning, then the arcade tends to end in the ventral premotor posterior Broca's area. If you use Forkel deconvolution, so you can resolve crossing better, you're going more anterior. That is because you can resolve the crossing in Broca's area with the fronto-aslan tract and the corpus callosum. Okay? Now, where exactly the tract goes, we still don't know. Okay, so I renamed my tract as the long segment of the arcade fasciculus. And that is because we have a couple more segments. Do you know which ones? No, Flavia made that point. The superior longitudinal fasciculus is not the arcade. Correct. So the anterior and the posterior segment together are the indirect segment. The long segment is also known as the direct segment. Now, coming back to the SLF, there's a huge misconception in the literature that is historically grounded that calls the SLF and the arcade the same thing. The differentiation is the SLF is a frontal-parietal connection. The arcade is a frontal-temporal connection, with the exception of the indirect pathways. So the anterior segment of the arcade fasciculus is SLF3. They overlap for most of its trajectory. They have slightly different termination points, but most of the trajectory for SLF3 only overlaps with the anterior segment of the arcade. So that's the frontal-parietal branch, and then the posterior segment is the parieto-temporal branch. So how would you go about identifying those two branches? Okay, say it again. You go to the origin and the end and exclude them.
And the regions of interest would have no gates in the parietal versus, so you have it
Yeah.
trying to excuse that.
Okay, so we already have two regions, right? Because the anterior segment is a frontal parietal and the posterior is a parietal temporal. So what's missing? The parietal, correct. So we need one more region. And if I orient my brain in a way that I can see Heschel's gyrus again, at the end of the lateral fissure, what's the gyrus? Supramarginal, correct. At the end of the superior temporal sulcus, which gyrus do I have there? Angular. Together they are the inferior parietal lobe. So we're gonna draw another sphere that sits right here, covering those two gyri. And that is our inferior parietal. Make sure that you do not overlap with your temporal region. Okay. If they get too close, you can move the temporal slightly down or reduce the radius. Okay, so let's do it. Just gonna click here. And I'm gonna create a new sphere. And change the color so it looks different.
So when we are drawing, why are we drawing so inside? So if the trap finishes here and here, why aren't we drawing like on the surface only?
You mean why we extend so deep into the brain?
Yeah.
That's because the white matter runs deep underneath the cortex.
Yeah.
And you've seen the maps earlier with the FA map where you lose signal as you go to the cortex.
Okay.
So if you just cover the surface of the brain, you're not going to get the white matter. So you have to extend your region into the deeper layers of it. Now, I placed my inferior parietal lobe region, but I also moved it deeper than the other structures. Sorry, no, more lateral. So the long segment is the deepest structure, and then the indirect segment is more lateral to it. Okay? And make sure they do not touch with the temporal region. Okay. Now, once you're happy with your region of interest, save. And then you can start building the language network. So I would start with the IFG again. Right click, create new track. And we've seen this before, right? This is exactly what we had earlier. But this time I select my track 2, your track 3, right click, and now I toggle my inferior frontal gyrus with my inferior parietal. And that gives us which segment of the arcuate?
Interior?
The anterior segment, correct. Or the frontal parietal branch, or SLF3. There's many names for the same thing. If you have it and you're happy with it, you can rename it by going into property and track 2. I'm just not gonna even attempt. And conveniently, mine came out in green, which is the color of the anterior segment conventionally. So I also don't have to change it, but save in between. What are we missing?
The posterior segment.
The posterior segment. How do we get the posterior segment?
we create the tracts that includes the like the parietal sphere and the temporal sphere.
That's exactly it. Off you go. The parietal sphere, create new tract, and combine it with the temporal sphere. I'm going to attempt to change the color. There you go. So if I now hide my regions of interest, there's your 3 segments of the arcuate fasciculus. Happy with it? You can do things like take the brains away, put the brains back in, do the tube rendering. There is a slightly different setting that I still want to show you. So you can see I have some writing here. Those are the tract labels. They're on by default. So if I go up into settings and render, so you have object annotation is on by default. So if I switch that off, my labels are gone. And then we usually also turn on the anti-aliasing, which makes it a little bit prettier. There you go. That's the sound I wanted to hear. And then you can either just take a screenshot, but a screenshot will always have the resolution of the screen you're working on. So the better option for papers is to go to save screenshot ×3, and that gives you a high resolution image of your dissection. And if you're not a big fan of black backgrounds, you can also change the background color to white, for example. I usually just cut it out, but reset. Let me bring the brain back. Now, I told you earlier that the the long segment is more medial and the indirect segment is more lateral. And you can see that because now we're looking from the lateral surface of the brain. And the first connections we see are the indirect segment, anterior, posterior. And when you spin around, you can see that the long segment runs more medial. Okay. That's quite important, especially if you do Klingler postmortem dissections, to know the order of the tracts as they should appear. Okay. Now, what I suggest we do for the next half an hour is we all did the left together now. You got to do the right on your own. And Valentina and I are here to help you. If you need it, feel free to help each other as well. But let's do the right hemisphere and see how it goes. 3 segments, right hemisphere, same approach. Go. Normalized into MNI. But if you have your own data set, you can open it in the native space, and instead of uploading an MNI as a background, you can use a T1, a T2, or any other map you have to guide your dissections. As long as it's co-registered to the diffusion data, you can use any of the native space data that you have. Okay? The reason we use the training data set in MNI is simply because that also lets you study the most standard anatomy here, so it's quite easy. But also you can upload an atlas. So if you were interested in doing that, if you go to the region of interest setting, there is the option from nifty or analyze image. So if you have a parcellation of the MNI brain, you could also upload a lesion mask for the motor cortex or the somatosensory cortex or whatever, okay? So that's why we use the MNI data for the training data set, but you can do exactly the same steps that we've done now in the native space of any participant. Yeah? Okay, who's ready? Who has an arcuate? 2 hands, 3 hands, 4, 5. Oi! Okay. Who needs more time? Okay, let's give it a few more minutes. Okay, that looks pretty good for most of you. If you want, we can take a picture whereby you turn around your screens. And if you don't want to be in the picture, you just hold the laptop in front of your face. Deal?
Yes.
Cool. First group picture. Here we go. So turn around your laptops. So we see the dissections. There we go. Come on, Fernando. Come on. Come on. Everyone turn around. Marcella. Okay. It's fine. No one can see it in the end. Here we go. 3, 2, 1, smile. Cool. Okay, we have about 15 more minutes. One of the questions that came up is how do you do the uncinate fasciculus? So the language network is often separated into dorsal and ventral, which we can have a long discussion about tomorrow if that actually makes sense. But part of the ventral connection is the uncinate fasciculus. What does uncinate mean? Hook. Just means hook, and it hooks together the orbital frontal and the anterior temporal. Now, knowing that in terms of anatomy, how would you go about dissecting it?
No.
More or less very frontal gyrus line.
Mm-hmm.
And then we add the narrow eye, sort of the temporal lobe.
Any other suggestions?
Temporal pole, frontal pole, and the anterior part of the what's the name? The stem, temporal stem.
Temporal stem, yeah. Any other suggestions?
Just the temporal stem and some exclusion zones behind.
Okay. Now, all of these versions work. They all work. So you can use the one you prefer. We usually tend to dissect the ventral stream together. So we do the uncinate fasciculus, the inferior fronto-occipital, and the ILF. And you can get those three together by simply combining 3 regions of interest. One is in the occipital lobe, one is in the frontal lobe. If you combine those two, which tract do you get?
IFOS.
IFOF. And then we put another region in the temporal lobe. So if I combine frontal and temporal, which tract do I get? Great. And if I combine temporal and occipital, there you go. So that is a quick way of doing it. And you find that in the chapter Flavio mentioned in his book. But because we only have 15 minutes, we can do a quick one in placing a sphere in the anterior temporal, a sphere in the orbital frontal, toggle them, and then probably add an exclusion to anything behind it. Ready? This is going to be a speed dissection. Here we go. So I click into the anterior temporal lobe, right in the middle, create a sphere, make it bigger. Whee, too big. And you make sure you cover the entire anterior temporal lobe. And then I do another sphere in the orbital frontal.
Would it be easier to use the axial interview to find the orbital frontal cortex, or is the same?
So if you do it axial, you have to do it slice by slice.
Oh, yeah.
So that's going to keep you busy for a while. What does work, however, is going coronal. So you see here we have the extreme capsule, the claustrum, and the external capsule. That's part of the temporal stem. So if you have an FA map, particularly, on the coronal section, if you go through here, there's a green dot because it's association fibers. So you could, if I just jump here. You won't see it now because we have a black and white map, but if you had an FA map, you would have a green dot right here. And you can just place your region right here and you get the IFOF and the uncinate together. Beautiful. Okay, if you're happy with your regions, we do the same shebang. So create a new track group. You can see we get a lot that connects to the oritofrontal. And then we combine it with, and in the interest of time, I'm going to cheat a little bit. So you can see I have my uncinate right here, but I also have extra connections here. So again, you would place a knot region here and just get rid of all of them. And I'm quickly going to do that. So we end with a pretty tract. Save. I'm just going to hand draw a new region of interest. And because we're not going for anatomical detail in this one, I can just, whoops. I can just place it here, make sure I capture all the tracts or streamlines that don't belong to the uncinate fasciculus. And then I can toggle that. Get my preview and exclude. And if I hide all my connections, there's your uncinate. So if you have the surgical cavity drawn as a lesion mask effectively, and it's registered to the same space as the diffusion, you can just go to region of interest and load from Nifty file. And that will give you the region of interest from the cavity. Or you would see it on the map here. So you could also draw it as a region of interest by going line by line, filling in the cavity. It's two options. Any other question? Yeah.
How sensitive is it for like Slavic structures and stuff? Is it also quite high? Or is it difficult?
So if you think back to the corpus callosum that we did at the very beginning, the projections we had were anterior thalamic projections. So you can pick it up. It depends a little bit on the acquisition. So the quality of your data will determine how much and how well you can pick them up, but you usually get them.
This one and like.
Okay, if there's no more questions, then thank you very much. You can start closing up, saving, and then that is the end of day one. Well done, you.